Good morning, everyone. We are group number 8, and we have been assigned by our company to design an IoT system with the aim to monitor the status of elderly people. Our project focuses on fall detection and heart rate monitoring for the elderly. We have signed a contractual agreement with the hardware supplier of M5 Stick watches and have utilized the M5 Stick C Plus watch to implement and achieve our project goals. In this session, we will be sharing the way we implement the Internet of Things in our project to achieve the given task by our company. We will also be discussing the safety concerns and design codes implemented during the design stage. The features and trade-off issues of our final product will be explained later in this presentation as well. The Internet of Things is a network of devices that are connected to one another. This technology allows the intercommunication between devices and the cloud to collect and transfer data using embedded sensors. This slide shows an overview of our project implementing the IoT technology. As shown on the screen, an elderly will have a M5 watch equipped on the wrist. The designed watch is capable of detecting fall as well as pulse. The watch will be connected to a Wi-Fi address and will be able to send notifications through Telegram to any smartphones that have an active internet connection. Hence, an elderly can be remotely monitored and help can be sent if an emergency were to occur. Due to the fragility of elderly people, constant monitoring is required. However, this is a difficult task to carry out without the help of smart medical devices. Diseases such as osteoporosis and orthostatic hypotension among the elderly can be developed over time after a fall. The World Health Organization has predicted that the population of elderly people will increase by 2050, which account for 20% of the world's population. Researchers have shown that fall prevention and detection devices have lowered the risk of hospitalization and death by 26% and 80% respectively. Hence, fall detection among elderly is crucial in solving financial burden due to injury and medication caused by accidental falls. The objectives of this project is to design a device that detects fall in real time, measure and monitor a user's heart rate, develop a warning alert system when fall is detected, as well as allow an easy Wi-Fi connection from the watch. The M5 Stick C Plus is a portable open-source IoT development board. It is powered by an ESP32 Pico D4 chip with additional features such as Wi-Fi, Bluetooth, infrared, real-time clock, microphone, red LED, temperature sensor, 6-axis inertial measurement unit, 3 buttons, a buzzer, and a power management unit. The MPU6886 is a 6-axis motion tracking device with a combination of 3-axis accelerometer and a 3-axis gyroscope. The MPU6886 also has a temperature sensor capable of detecting temperature between -40 degrees to 85 degrees. The accelerometer used is the micro-electromechanical system. It has a low cost and is small in size. However, it has a low accuracy compared to accelerometers such as piezoelectric and piezoresistive. The pulse sensor used in this project has one LED and one ambient light sensor. The front side of the pulse sensor is responsible for pulse detection, and the back side of the pulse sensor has a circuitry, and this is where amplification and noise cancellation works are done. The pulse sensor works by monitoring the blood flow in the veins of human body. When the flow of blood is detected, more light will be reflected and received by the ambient light sensor. The change in light will be analyzed over time to determine a heartbeat.
As our project focuses on the design of a medical device, there are several safety concerns along with the design codes and standards that are required to be met. In terms of safety, the final product is expected to be safe for users to use on a daily basis. Two important design codes that were taken into consideration while working on this project were the IEEE11073 and ISO 13485. IEEE 11073 is one of the main standards that has to be fulfilled by all medical devices, so it has a huge impact on this project. This standard is mainly applicable for personal health devices, or in short, PHDs. It defines the ability for several different systems to exchange data, which in this case is the health information, and use it as soon as it is received. It also allows users to track their health condition and transfer the information received to healthcare professionals if needed. Our proposed design will be able to meet the requirements for this standard, as the M5 Stick C watch is able to detect falls through the received data. Once a fault is detected, the watch will notify the predefined emergency contact immediately. The slide shows some examples of the personal health devices where they are all manufactured according to this standard. Here we have the glucose meter, weighing scale, blood pressure monitor, ECG, insulin pump, as well as the sleep monitor. Next, the ISO 13485 highlights the quality management system that requires an organization to produce medical devices that can meet all customers' requirements. These medical devices are evaluated based on several aspects of quality to prove that they meet the medical standards. The design will be evaluated based on a few quality aspects such as software functionality, data confidentiality, quality of data transfer, electrical and electromagnetic compatibility, biocompatibility, and physical-chemical stability. Method of evaluation is shown here in this table, where all devices are checked based on whether they have met these requirements or not. For example, if the performance of the system is good with no bugs issued and measurements recorded by the watch are all accurate, this software functionality is achieved.
For our product features, we have two main features, which are fall detection system and heart rate monitoring. For our product's additional features, we have warning alert system to Telegram and semi-automated IoT Wi-Fi connection. For our main feature 1, fall detection system, we are using a threshold-based method and utilizing the MPU 6886 accelerometer and gyroscope in the M560 Plus. And now I'm going to introduce to you our group's fall detection system flowchart. At the start, when button B is pressed, it will act as an emergency button and send an fall detection alert notification to the Telegram. If the button B was not pressed, it will continue to calculate the acceleration magnitude AM using the equation shown in the left side. If the AM value is less than a certain threshold value, it will continue to calculate the angular velocity AV using the equation shown in the left side. After calculating the angular velocity, it will determine whether the angular velocity is within a certain threshold. If the angular velocity is within the threshold, it will continue to sound the buzzer on the M560 Plus, and it will have a 10-second period time for the user to either press the button A to cancel the fault detection system or continue and allow the M560 Plus to send an alert notification to the Telegram. If the buzzer has finished beeping for 10 seconds and the user didn't press the button A to cancel fault detection system, the M560 Plus will continue and detect the fault and send the alert notification to the Telegram. After the alert notification has been sent to the Telegram, the M560 Plus will continue on beeping until the button A is pressed. And after the button A is pressed, it will cancel the M560 watch buzzer beeping and send a new message to the Telegram alerting that the cancel button has been pressed. Next, I'm going to talk about our product's second main feature, which is heart rate monitoring. For heart rate monitoring, we will be using the M560 Plus pulse sensor and also Arduino IoT Cloud. For the M560 Plus, we will be using the ESP32 Wi-Fi connection and perform the BPM calculation and also send the data to the Arduino IoT Cloud. Next, for the pulse sensor, we will be using it to read the pulse because it has an inbuilt signal amplification and noise cancellation circuit, and it uses the wavelength of 500 nanometer of green light and less affected by ambient light, and also the light is absorbed well by our red blood cell. Lastly, we will be using Arduino IoT Cloud to monitor the heartbeat per minute, and the BPM is updated to the Arduino IoT Cloud every 5 seconds. The Arduino IoT Cloud will be available both on web browser and also phone. After the data is recorded on the Arduino IoT Cloud, it has a function to export the data to the Excel sheet. During our research, we have found out that the M560 Plus have two cores available. So for parallel processing in our product, we will be running the BPM calculation on the core 0 and the fault detection system on the core 1. And the parallel processing flowchart is shown here. For parallel processing, first we create a task handler, and inside the setup of the code, we will assign the task to a specific code and set the priority of the task. A function will be pre-created, which contains the code for the task to run, and the task will determine to either run infinitely to prevent any error, or after running the task, we will use an vtask delete function to delete the created task. Now, I'm going to explain to you the heart rate monitoring flowchart. At the start, we will be using a millisecond function to determine how long have the F5 Plus been powered up, and using the millisecond, we know we can count the number of pulses within the 5 seconds. If the 5 seconds have not been reached, it will continue to read the analog pulse sensor, and after 5 seconds have been reached, we will perform a BPM calculation based on the quantum bits in 5 seconds. After performing the BPM calculation, the BPM value will be updated to the Arduino IoT cloud. And the heart rate monitoring function will only be stopped if the F5 Plus has been powered off. And now we are going to introduce to you our additional feature 1, which is a warning alert system. And the flowchart shown over here is for our additional feature 1, warning alert system to the Telegram. For alert system to the Telegram, we first need to set up the bot token and chat ID. And then after setting up the bot token and chat ID, we need to send a root certificate for the api.telegram.org. After root certification has been sent to the api.telegram.org, a message will be sent to the Telegram mobile app stating the Fi watch has been started up successfully. The warning alert system will continue to monitor for fault detection, and it will only perform action only when the fault detection has been detected. If the fault detection has been detected, we will wait for the user for 10 seconds to determine whether the user want to cancel the fault alert. And if the fault alert was not cancelled, it will continue to send the alert message to the Telegram mobile application on our phone. And if the fault has been detected and the front button pressed to cancel the buzzer beeping, it will also send another message to the Telegram stating that the buzzer has been deactivated. The warning alert system will be continue running until the F5 Plus has been powered off. Next, I'm going to introduce to you our additional feature 2, which is semi-automated IoT Wi-Fi connection. And now I'm going to explain to you our additional feature 2, which is semi-automated IoT Wi-Fi connection flowchart. First, when the F5 Plus is powered up, it will scan for non-Wi-Fi, and if the non-Wi-Fi was scanned and SSID and password was correct, it will have a successful connection to the internet. If the F5 Plus did not scan any non-Wi-Fi, it will set up itself as an access point, and the user need to connect to the access point using the desktop or mobile phone Wi-Fi feature. And after user has connected to the access point, the user need to key in the 192.168.4.1 in their web browser. And after opening up the web browser, their user need to key in their Wi-Fi name and also password. After the user have keyed in their Wi-Fi name and password, the F5 Plus will send the received data and restart itself as a client. And the flowchart will back to here. The F5 Plus will scan for non-Wi-Fi. If the user input SSID and password is correct, it will connect to the Wi-Fi successfully.
Now I'll be presenting on how the device is tested. First, as shown on the slide, is how we equip the device before testing. The left image shows the top view, the middle image shows the side view, and the last image on the right shows the default state of the device screen when testing. It is noted that we have two tests. One is falling position test and the other is daily life activities test. For the falling position test, we decided to have 3 different falling positions. First, falling on the front. Second, falling on the back. Third, falling on the side. From these tests, it is expected that the device is triggered more often. Next is daily life activities. We also have 3 but different activities. First is walking. Second is sitting and standing up. Third is lying down and getting up. From these activities, we are expecting the device not to trigger its warning. The lesser the better for this case.
Moving on, I'll present the further improvements that can be done in order to increase the functionality of the device. This covers the battery saving mode as well as the receiver notification alert. The purpose of implementing a battery saving mode is so we can increase the battery life of the device. Currently, the M560 Plus only has a battery life of 80 minutes, which is bad, considering the fact that the user has to charge the device multiple times a day. This is highly inconvenient, and therefore, a solution has been made where a deep sleep mode function is used to put the device to sleep when not in use. This will reduce power consumption and increases its battery life. One other improvement is the receiver notification alert. Currently, our device is only programmed to notify the receiver once when fall is detected. In cases where the receiver missed the alert, no help will be sent to the person in danger, which is why this improvement is needed, so the receiver will be notified with a continuous alert until it is deactivated manually.
To conclude our presentation, a summary of our achievements will be done. As seen in the table on the slide, a series of scenarios were done to test the fall detection functionality of the device. The sensitivity, specificity, accuracy, and false positive rate are calculated. The device is also able to read the heartbeat of a person when a pulse sensor is connected to the device. As seen on the slide, the detected heartbeat pulse will be converted to beats per minute and displayed on the Arduino Cloud IoT dashboard for monitoring purposes. The proposed warning alert system using the Telegram app is also achieved. Once the device detects a fall, a notification will be sent to the Telegram app successfully. The device is also equipped with a semi-automated IoT Wi-Fi connection. When the device is started up, a QR code will be displayed on the screen of the M560 Plus. The QR code redirects the user to a web page where the setup of a Wi-Fi connection can be done. Once connected, the device will store the Wi-Fi details and automatically connects to the same network when it is booted up in the future. We hope that our final product can ease the monitoring process of elderly patients, hence increasing their life expectancy. Thank you for listening.